Hello guys, welcome back to another video on further maths Edexcel and complex number video number 2. This would cover exercise 1F of the green book. It talks about use of complex numbers in solving polynomials. And before I go into the book questions, I'm going to be talking about some things which are important for understanding the solving polynomials. Okay. Step 1 is if I give you two roots or two solutions to a quadratic equation, how would you write a quadratic equation for it? I'll just show you what I mean by this. Alright, so this is the question. Write a quadratic equation in x which has x equals 2 and x equals 3 as its roots. So this is generally the opposite way of what we've been learning about quadratics up till now. So this is actually, we write down x, take away the first root in one bracket, x, take away the second root in the other bracket, and equal to 0. Right, so we work it out and then we get the quadratic equation which will have x equals 2 and x equals 3 its roots. And the answer turns out to be x squared minus 5x plus 6 equals 0. Why I'm doing this work with you over here is I want you to understand a very important part. Guys, see what happens if you add the roots. We call that sum of the roots. It is 2 plus 3, that's 5. And if you multiply the roots, which gives you 2 times 3, 6. And you can see these two numbers are actually part of the equation. Okay. And we're going to try and generalize a formula or a rule, a very important, powerful method which is going to help you. Give you a couple of seconds to think about it, and I'll come back. So if you look carefully over here, you got x squared minus 5, which is the sum of the roots, and plus 6, which is the product of the roots. So in general, simple cases, if you have two roots given to you of any quadratic equation, you've been asked to write the quadratic equation, you can use this simply. I'm going to extend this slightly a little bit more. Okay. So right, in general case, a quadratic equation is ax squared plus bx plus c equals 0. You can relate this back to your GCSE, normal maths. You've been working on this using formulas, calculator, factorization. Sum of roots of the two answers, the sum of will be is minus b over a with the negative sign, and the product of root will be c over a. Guys, this generally works true, and I'm expecting you to memorize this, and we can obviously verify this as well. Let's see if you can verify this in one of the questions here. Right, so using the same rules above, let's see if you can find sum and the product of the roots of this quadratic equation without actually working the roots out. So sum should be, that's a, and this is b, and this is c, should be minus negative 3 over 2, and the product should be positive 1 over 2. So sum is 3 over 2 and product is 1 over 2. What I would like you to do now, use your calculator to work out the two answers. Then we see if the sum and the product of these two answers match with what we've got. So your calculator gives you these two answers, and you can verify. If you add them, you get 3 over 2, and if you times them, you get half. So this rule is verified. This is what I would like you to memorize. It helps, guys, if you know it in your top of your head. Okay, if it's a quadratic equation, sum of roots is minus b over a, and product of roots is c over a. The next major step in use of complex numbers, solving polynomials, is for any polynomial, you got to know that complex number occur as a conjugate pair. What does that mean? If it is a quadratic, cubic, quartic, or any 5th degree, 6th degree, whatever polynomial, if it has a complex root, then definitely it will have two complex roots as a pair. If it has two different complex roots, that means it's bound to have 4 complex roots altogether, 2 pairs. Complex root cannot occur as a single thing in itself. It has to occur as a pair. I'm going to explain to you a bit more what do I mean by this. Okay, so with that, what I'm going to do question number 4 of exercise 1F in the book. It says this polynomial equals to 0, this equation as x equals minus 4 plus iota is one of the solutions. They've given it to me. Find the other two solutions. I've just used x there because we normally use x, even though the book is using z. It does make a difference. As long as these coefficients are a, b, c, d are real, it works for everything. Right guys, the other two solutions. I've got one solution as minus 4 plus iota. Okay, what does that tell me? The second solution will have to be using this, the conjugate pair of this, that will be minus 4 minus iota. So I've got the two roots. So how many more are left now? One more. Okay, if I know the two roots, can I make a quadratic equation which has these two roots as the solutions? I'll use the stuff which you've learned in the top. Okay, x square, sum of roots and product of roots. Okay guys, this will be x minus 4 plus iota as one factor, and x minus 4 minus iota as the other factor equals to 0. So this should be the quadratic equation which has these two roots. Okay, let's work that, which on simplifying gives me this. And if I look very carefully, there's a positive 4i, there's a negative 4i, there's a positive ix, there's a negative ix, which cancels. So the quadratic equation comes out as this, which complies with the fact we learned earlier. If you do x squared minus sum of roots times x plus product of roots equals 0, this will also give you this equation. But now what does that tell me? Because these two were the roots of this cubic, and these two are the roots of this polynomial as well. That means this polynomial should be a factor of this one. So we're going to be dividing this long thing by this using a long division, which we learned in the first year. And the division gives me this result. What does that tell me? X minus 4 is the third factor. I put that equal to 0. I got x equals 4 as the third solution. So the three answers are, or three solutions are, minus 4 plus iota, minus 4 minus iota, the conjugate part of that, and 4. So this quadratic equation, this cubic equation has got one real and two complex solutions. The next question we do in here is question number 10 from exercise 1f. This is the question. It says write in the form of z square minus 9 times by this, a quadratic times quadratic. So I know this factor, so I would need to divide given polynomial by this factor to get the remaining quadratic. Then we need to solve this. Okay, let's do that first, do the division first. Or you can use comparing coefficients as well, whichever method you find convenient. Okay, I've done the division once before, so I'll do comparing coefficients now for you. Okay, comparing coefficients of, let's say, z cube. We got negative 12 on the left hand side, and this should be equal to z squared times bz gives me b. So then another z cube term I'm going to get from, that's it. We're not going to get any more z cube terms, so b equals negative 12. Okay, let's say comparing coefficient of z square now, and z square terms, I want to get z squared times c, which will be, on the left side it is 31 first, equal to z squared times c is c. Then minus 9 times z squared is minus 9, and this is it. I cannot get any more z squared term. Once again, this is z squared term, this is z squared, that's it. So c gives me as 40. Right, so the answer of this would be z square minus 9 and times z square minus 12z and plus 40. Okay, hope this is right. We can. And finally, to solve this polynomial completely equals to 0, we need to solve this and this, the two quadratics. This gives me z equals plus and minus 3, I think. Okay, the two answers, and this should also give you a, I think this will be complex solutions. You can use your calculator to work that out. And that finishes the video, people, and we will come back to it with the next topic, which is arc and diagrams video soon. Thank you very much. Happy learning. Bye.